All right, welcome again to We Can Only Hope Our Good Choices We Will See in time. But for now, I'm gonna. I just want to finish out building this lab and like getting everything all set to automate. So we made some really good progress. I mean, we didn't make progress in figuring out. Let me ask the AI. Okay, so AI is great. I love it. Let's ask it a question. Okay, so I'm in GNS3 and I set up a lab, and now for some reason I can't drag on the screen to reposition the lab. What is going on, and is there a way to do this? Oh, it's a bug. Select mode. How do I get into select mode? Select mode. How do I get into select mode? Where's select mode? Okay. So there should be a pointer icon. There is no pointer icon. What mode am I in right now? I'm in select mode, aren't I? Man, this is rough. Maybe I need a dock or something. Where's select mode? What if I right? No. Let me reset the docks. What if I do a select all? No. Yeah, there's no pointer. There's no select mode. I don't know what they're expecting there to be, but it's not there. Uh, yeah, okay. Well, I don't know. Oh, the zoom level? Maybe that's it. Uh, okay. Um, oh, here's okay. I'm able to change it into a hand if I hold down shift, but I'm still not able to actually move it around if I do that. Um, so how do I go into select mode? There is no selection tool pointer icon in the toolbar on top of the GNS3 GUI. It seems to be missing for some reason. If I hold down shift and move my cursor around, then it changes into like this closed fist icon, but it still does not re-navigate my position in the lab. There's no scroll bars on the bottom or the right hand side, and half of my lab topology is cut off onto another screen, and the only way I can see it is by zooming way out. But if I do that, then I can't see the details of my topology.
I understand how frustrating it can be to deal with interface issues when you're trying to work on your topology. It seems like you're facing a way glitch or some other kind of bug. Let's try to work through it. Step 1. Reset the view. You can try to reset the view to its default setting. This might be available in the view menu, where you could find an option like reset view or default view. Step 2. Check keyboard shortcuts. GNS3 supports several keyboard shortcuts that might help you here. Try the following. Control+O, Windows, or Command+O, Mac, to reset the zoom level to the default. Control++, Windows, or Command++, Mac, to zoom in. Control+-, Windows, or Command+-, Mac, to zoom out. Step 3. Pan around the workspace. If you hold down the spacebar and then click and drag with the mouse, it should allow you to pan around the workspace. This might help you to reposition the lab to a more central location on the screen. Step 4. Enable scroll bars. Check if there's an option in the settings or preferences to enable scroll bars, which might be under view or interface settings. Enabling scroll bars can allow you to navigate the different parts of the topology more easily. Step 5. Workspace adjustments. If necessary, you might try adjusting the size of your workspace. This might be available in the preferences or settings, where you can set a custom size for your workspace to ensure everything fits properly. Step 6. Reinstall or update GNS3. If all else fails, you might consider reinstalling GNS3 or updating it to the latest version to resolve any potential glitches or bugs. Give these steps a try and let me know how it goes. If none of these work, we might need to look into other solutions.
It just like doesn't fit. How do I resize it? Oh, if you hold down. So it is working if I hold down the it probably even works with, yeah, so if I hold down the shift bar, or if I just hold down the middle button, then I can like move around the space. But the thing is, like, the toolbars, like, it doesn't know that there's more to the right. Like, if I, and now it's like there's nothing there, so it's like the size of the space is wrong. I need to, like, yeah, so I need to adjust the size of my workspace. So let's go to settings. Yeah, preferences, general. We'll do like workspace. Default. Oh yeah, I think this is it. We have to change the default width to like as much as we can. Or so let's just change everything to 10,000. Was that not enough? I think this is close to what we need. Oh, let's change this to 10,000 as well, or to the highest. 150 is the highest. Change this to the highest as well. Oh, that was the lowest. 100 is the highest. Okay, that's an invalid grid size. Let's show the grid. Okay, this is the grid. We can snap it to the grid. I'm so confused. It's not fitting in the view. Just add another one. Can I do that? It's, yeah, there's something. See, I can't see my lab. Like, if I go all the way, it still cuts it off. It's just so frustrating. Like, if I put it here, which you would think would make sense, because now it's at 0, 0, and like it's not that bad because I can use the middle mouse button. But like, look, it's like resetting it to 0. And like, if I zoom in, I can't go over to that side. All right. Well, you know what? I think that's it for that. It's about 10 minutes in. I'll keep this part of the video and not cut it off. Sorry, not really reading much in the book right now. Just trying to get that lab to work. Oh, and now I've got it set up to snap to the grid, which would be good if I didn't have all these. But I'm going to turn that off. I think I'm even going to show turning the grid off. I like the grid. I like the grid a lot. Let's keep the grid on. But let's not have it snap to the grid. All right. So now let's go ahead and cable everything up. Okay, so we notice there's like kind of a mistake or whatever in the topology. We've got these port channels here, but then we're missing 2 here. I don't know if that's intentional. I'm guessing it's not. But we can see it should be pretty easy. There's no cabling between the access layer switches just from the core, and then there's those redundant connections. So let's start off by adding the links between the all the distributions. And then we have the management network for the out of band. We could simulate an out of band network. That'd be kind of cool. Okay, there we've got it there. Now we've got a set of it here. Right in a set here. All right, and then let's go ahead and do that with the core as well. The core is going to need those links. All right. So now let's wire up the core to each of the distribution layers. We're going to start top down. So it looks like we'll have 4 connections to each of the distribution devices. So we'll have 2 from each core. So let's do that. So here's the first connection. Okay, and then here's the second connection. All right, and now to the next core, or should the next distribution device. We can see pretty quickly the eccentricities or the challenges when it comes to building out networks, and especially when it comes to like purchasing devices, because you're going to have a fixed amount of ports on these. So like if you buy the physical gear, you've got a lot of considerations to make, and if you get those wrong and you run out of ports, it's not quite as easy as it is in the lab. And if it's a fixed switch, you're absolutely screwed. If it's a modular switch, you can add ports in. Yeah, we can see I'm already out of ports on these core devices. These were not a good choice. Shoot. Oh, and this isn't even cabled correctly. Oh, I think we're going to have just enough. That would be crazy. All right, these look good now. Yeah. Yep. Okay, those look good. So the next part is these. Hopefully we'll have just enough. No, we're going to be exactly one port short because we got to go from here and then to there. But we can just add one. There we go. But you can't do that while the links are there. Let's go back to our discussion about what a core network looks like. I wish you could search through this. Because, like, we had a really good chat about this. Well, shoot, I don't remember where it was. Yeah, I don't remember. You know what? We can just do it again. I remember how to get these images. So, and you know what? I think I remember. No, I don't. I wish I could get to that again. I don't know why it's so hard. Oh, okay, this is it. It looks like it does refresh up to the top when you continue on it. So yeah, I found it. Okay, so perfect. Okay, so yeah, it's just in this nexus for the core, but I asked it further, and I think it did have some other ones. There's just not enough. So the Arista could be used for the core instead. Also the extreme. Let's take a look at. So the Aristas are right here. So let me start one of these. First, let me see how many ports there are. Okay, so 13. That could be better. Now what we need to see is that there's 10 gig and higher. Now, if there's not 10 gig or 10 gig, we can't even use these in the distribution because they won't hook up into our 10 gig ports in the core. So let's drop the extreme and hopefully that will work. Oh, was it what did it want? It wanted an extreme EXOS. Yeah, I wanted this. All right, so we can start. So let's take a look at how many ports coming on by default. 13, so that's good as well. And then it uses these real techs by default, so that could be good. All right, so we got our Arista here. Then we need an extreme as well. All right, and I gotta pause it. I'll be right back. All right, welcome back. So we're kind of still having trouble in the lab here. I've got both of these devices up now, but we can see that the actual like what these devices are capable of isn't listed here the same way it was for the Nexus. So I have no idea what I'm working with here. So let's try to figure it out. Let's cable it up and see what the biggest cable we can get. So we'll go in port 12 here to port 12 there. And then we should see like line protocol up or something, unless we have to no shut it. But if we have to no shut it, that's okay. We'll try to figure that out. So we do a show inscription on this Arista. So now we have this MA1 up. I'm not sure. And some of these are, it's virtualized, so it's going to be kind of weird. Oh, here we go. So we can see we do have an LLDP neighbor right now. So let's do that. Show LLDP neighbor. Okay, so we've got the EXOS showing up there. We'll do it on this side as well. And there can be like I think no logging. Yeah, no logging console, get rid of those annoying messages. Alright, and then on this side, let's do a show LLDP neighbors. There we go. So we're looking good. We're on Ethernet 12. That means that the port is probably like up in a way. Let's try setting the ports. So configure port or configure and then ports 12. Yeah. And we'll set the speed. Or we can set it to auto negotiate. Speed can be advertised. So let's see what happens on the wire when we enable this. Okay, so we're doing a DHCP. Don't have a server. Okay, now we've got a LLDP. I mean, that's normal. We have STP going. Shoot. So we have link aggregation stuff going. So aggregation, I mean, that's like for port channel stuff, right? Not sure what that's all about. We have a VLAN idea on it. Yeah, VLAN 1, it looks like. Capabilities, this is probably... No. I want to see what that message looks like to negotiate. We have a frame size. So this is good. It's capable of jumbo frames by default, so... Looks like it could be a big core, a port that belongs on a core switch. Yeah, it's just got nothing. Oh, here's information about the port, but we don't have anything like the speed. Here's EDP, which is the extreme version of LLDP, kind of like how Cisco has CDP. It's the same thing for extreme gear. So here's some information about the port itself, but I don't see anything when it comes to the speed of the port. Yeah, I got nothing on that. So let's try to mess with this one a bit. Okay, so here's ETH12. We still don't have. Let's turn auto negotiation on this one. Okay, so this is a good sign. It looks like at least the software is capable of. Oh, and it looks like, oh, this is a really good sign. So our only options are, I guess we do have some like really small links, but it looks like a lot of the options we have are for like 100, 400 gig links. So this might be the ticket here. I'll do a shut no shut on that, so hopefully it triggers that negotiation process. All right. Okay, so here we go. We've got a 100. It negotiated at 100 megabytes. I'm assuming. Let's see if we can get some more information. Okay, here's probably the most detailed information we can get. Yeah, so it negotiated 100. That's no good. That's really bad. So we get anything here? It still says that auto negotiation is off. I don't know why this one is not doing a good job. That's kind of interesting. So let's try let's do a configure terminal. Okay. And then we're going to do a speed. All right, and then let's force it to like 100 gigs. So we've got 1, 2, and 4. Over lanes. I don't know what that means. Let's just do the 10 gig. Okay, and then we'll do a shut no shut. Okay, and then hopefully we'll get some better information here. So it's still at 100. Still at 100. And I wish I could see the speed on there. So it says it's unconfigured still. Maybe it's still coming up. Shoot, I need that 10 gigs. All right, well, I got to pause. I'll be right back. I did not pause. Alright, welcome back. I've got 30 minutes up on the clock, so I guess I might as well keep going with this. I'm trying to do the cabling, and I'm trying to get high-speed links up to my core, but it's just not that easy. It's hard to simulate this stuff. So I want to just throw the links up, but where I was last is I ran out of ports. My devices I chose for my core didn't have enough port density, which I mean is fair. Like, these are, especially the Nexus, they're modular devices. They're not fixed devices. So like, yeah, you're just supposed to slot in more modules. They're not supposed to just have that many ports on them without there being the appropriate modules slotted in. It's not like a Catalyst for where you just buy it with it's a fixed switch with a high port density. You know, you have to slot in modules. But so we ran into a bit of a problem because they're not like super high port density. We have another problem too where for some reason I can't move around in my lab. Like, yeah. But anyways, all these links have got to go because there's just not the port density, and then you can't change the port density when it's cabled up. So that's what I need to do now, is to delete all these links. So I will do that. Yeah, I need to delete every single link, and then we'll add like a ridiculous amount of ports because we need room for expansion. Like, let's say in this office, this is an office building, as I talked about before. It's kind of not ideal either, but let's say we're just renting out the first floor of it or whatever. Like, if we need more floors, we'll need to get some more distribution devices and hook them up to the core. So we will need some ports in the core to be there extra ready to go in case we need to add some more floors. I'm kind of tempted to work backwards because let me do a mic check, because when I step away, mic check 1 2, okay, looks good. I'm kind of tempted to work backwards because this issue of port density might rear its ugly head later on, but it's fine. So we've got 10. Let's double it to 20. Okay, and then this is para-virtualized. Let's make sure that they're both para-virtualized. Yeah, this is not para-virtualized. We'll just make everything para-virtualized. And I'm not sure if I can do it on these. Yeah, some of these are set to 100. Let's set them all. Let's just go through and set every single one to para-virtualized. So we start there. Now, I don't know what this VMware. I'm not using VMware, so obviously I don't want that one. That one looks good. Looks good. Looks good. Okay, so yeah, all of these look good. They're para-virtualized. We talked about the AI about this part, and I don't know. It recommended using the para-virtualized option, but I don't really know the difference between the options. I think if we want our 10 gig and 100 gig ports, we do need to make the right selection here under type. But you know, we only have those types. We could do like a custom adapter. But see, we only have these options to choose from, so I don't know if we'll get 10 gigs with any of that. But I'm pretty sure like an E1000 will hard limit us at 1 gig, so I think that's definitely not the right one to use. Alright, these are paravirtualized by default. Okay. And then these I already have. I kind of hate to keep double checking things, but it's just like, it's one of those things where like I'm never going to notice it too. It's just like a needle in a haystack. It's so annoying I have to do it this way. Oh, and it doesn't track proper. You can't control Z a movement too. It's just so bad. All right, that looks good. Yeah, you can't shift it up either. There we go. All right, let's make sure everything's paravirtualized. These are different kinds of interfaces. So we only got 4 devices left. Perfect. Yeah, we definitely don't want the 1000 because then we don't have the option for 10 gigs and 100 gigs for sure. All right, there we go. So now we can probably do the cabling and get by. We've got a lot more ports on our core. We've got everything set to paravirtualize, so maybe we can do 10, 100, 40 gig, 400 gig backbone links to the core. So let's give it a shot. We might run out of some room on the distribution, but we'll deal with that when we get there. All right, so pretty easy. Just plug everything in. So we'll start with our port channels. All right, and we'll just go from left to right. Sometimes when you get creative with a scheme and like you're like, oh, 1 goes to 1, 2 goes to 2. It's like sometimes it's just like what you're trying to do when you do that is get away with like not having to use documentation. And it's like, no, you have to use documentation. So I recommend just plug everything together and rely more on your architecture, on your documentation than your, fairly arbitrary decisions about what ports everything is plugged into. It's almost in a way like a feature, not a bug, that you can't always like cleanly plug in like 5 to 5 or anything like that, because then you have to get your documentation in order. Otherwise, you could just like get by. All right, looks good to me. So now next to this stuff. All right, so we got our core all hooked up now. And if we wanted to expand our network out to add more floors, we just add more ports or we just add more connections. Yeah, so we've got, let's see here. Yep, all the way up to 10 is filled in. So we can double the size of our network. Well, maybe not double, but we could add plenty more floors here and be totally fine. I might do that at some point, but yeah, we're good to go. So next step will be to configure the distribution to the access layer, and that's going to be done in like a full mesh like this. But the access layer switches aren't going to be together, so should be pretty easy. Oh, port's not free. Okay. Now, sometimes I'm not sure if these are like management ports. Let's just do it to one, because sometimes I'm not sure if yeah, because sometimes it's not labeled correctly to what it actually is. So I am noticing that these access switches are like different, which kind of is a problem for me. But yeah, this looks good. And then we'll have these two employees work off of here, and then these two unique and special P number employees work off of here. All right, that looks good to me. So now we gotta hook up everything else. So let's take a look at how the firewalls are. So the firewalls are the full mesh, and then these are just straight off from the firewall. So let's start there. Yep, so we're straight off from the firewall, and then we're a full mesh here. And it's not quite a full mesh because the firewalls aren't hooked up together, but it's definitely a mesh topology. It's just not a full mesh. It's a partial mesh. It's a complete mesh. Sorry. Okay, so yep, firewalls aren't hooked together. So the last part is the WAN. So it looks like the WAN is kind of an interesting, yeah, because we've actually got two connections going in. So I think these only have one, but these are other ones where I can add interfaces. Just add an interface, and then this one I think already has two. Oh, but I need a connection for my. But the thing is, like, my automation server can go, like, it can go anywhere on here. It should probably go like in the data center. Actually, that's probably the best place for it. Because like we're gonna have like a VLAN scheme. We're gonna have our routing ACL scheme. We don't want our precious trusted P employees to be able to log into the firewalls unless that's their job. But these people, we really value them in the company, so they're just gonna be like off in the corner somewhere. And I think this guy's name is Ted. I don't know. Oh, it's John. Okay, well, it's P12346. There we go. All right, so let's go and make these connections. Oh yeah, and we're out of ports on this one because we've already got it hooked up. Let's just put 4 ports on each of these, just because that's a good number. You know, having room to grow is always good. Oh, it looks like all we can do is 4 too. So yeah, might as well just max it out right away. Now in the real world, you really do got to do the math. You got to be good at designing networks, because otherwise you're just going to break your budget for no reason. So you got to keep things within the budget, and you got to make the right choices about how much to spend on what. But that's the real world. Now this you definitely wouldn't want it to work this way, where you're coming into the network through the internet. Definitely don't want it to work that way. But that's how I'm going to have it for now. And honestly, you know, this would be fine. Actually, this is the way you would want it to work, to be honest, because you would want you'd want to like hire contractors out to like work on your network, and you give them like a VPN. So yeah, this is what you want. Oh, it looks like I didn't label this one correctly. Let's change that. So it's gonna be yeah, INT for internet, and it's gonna be firewall 01. Okay. All right, so now all the cabling is complete. Not quite all the way there yet, though, because we do need to verify that the links are okay, and it could get really messy where it's like the links are not okay, and not only that, we have to use a different device. And I don't even have the device we need. What we really need is a catalyst, because you know this is an office building. Like here, the Nexuses would be good for the data center, from what I understand. But like for this core, we really need a catalyst better. And I have a template for one, but these images are, don't come cheap. So it'd be cool if I could use the SD WAN for the WAN. That would be really cool. All right, but let's boot this baby up and see if everything just explodes. So we'll look at the server summary and take a look at how taxed it. I mean, my lab is like pretty beefy, but especially my lab kind of lacks a little bit of CPU. So let's see how this goes. Yeah, so we're already at 64, 88. We're not at 100, which is good. RAM is very low, especially since these are really beefy RAM devices. Perfect. Yeah, it seems to run really nice and squeaky clean. Kind of a high CPU because that's the limitation of the choices I made when I built out my lab. But really low RAM. Again, I could have saved money by having less RAM, or just invested more in CPU, and had a better lab for the same amount of money. But hindsight's 2020, and I'm actually really satisfied. This lab cost me less than $600, and look at this. I've got a full. This is it. I mean, this is your workplace, your hospital, what have you. This is it. Like the floors, you have a distribution devices, you have access devices all throughout the floors, and people plugged in. I mean, this is it. Now you're gonna have like wireless stuff, which I wonder if I have like a wireless access point, something like that. I'm sure I have it as like a template. So I think it would be a guest. So it's an AP. It's a wireless access point. So it's really kind of none of these. Like maybe it'll come as a switch. No, I wouldn't think it'd be a router. But there's some firewalls there. Yeah, so I don't see any like access points or like wireless equipment, because that's what you'd have. Like sometimes it's hard to, as you're going through your CCNPs, even like the CCIE, it's like, are we really learning about like a wired connection in this way? Like that's not how it happens, right? It's usually all wireless. So it's like this in an office building, you probably are going to see this, to be honest, because wired has some advantages, but you would also see it'd be more common for this part to be missing, but the wireless part that we have missing here to be present. So it's kind of like the opposite of what you would normally see, but I think in most cases you would see both. But unfortunately, I don't think I'm able to do that. I need to pause. I'll be right back. All right, I'm back. So yeah, everything's really good. As I said, we're kind of not really on track here. You know, we're simulating a campus office building, and in this case, one that has their own data center on site. They're not even using like cloud services, and then they're not even using like wireless either. So like, you know, we should have like floor one for our workers, but we should also have like, you know, public Wi-Fi in our lobby for like, you know, business associates or like workers' family members like out there in the lobby. Like we should give them Wi-Fi. That's like a standard thing that companies do. Like that's just putting a good face out there to the world. If we can't even do that, people will be like, oh, this place is terrible. It has no Wi-Fi. So let me ask the AI about that. Okay, so here's a question. I'm in GNS3 and I want to simulate wireless connections. How can I do this?
In GNS3, simulating wireless connections isn't straightforward because GNS3 primarily simulates wired networks. However, you can emulate a wireless network environment using certain workarounds. Here's how you can go about it. Step 1. Set up a virtual wireless router. Download a wireless router OS image. Download an OS image of a wireless router. You might use images from vendors that offer wireless solutions, such as Cisco, Aruba, etc. Install the wireless router in GNS3. Import the downloaded OS image into GNS3 and set up a virtual wireless router. Step 2. Simulate wireless clients. Use virtual PCs. Use virtual PCs in GNS3 to represent wireless clients. Connect virtual PCs to the router. Connect the virtual PCs to the virtual wireless router using Ethernet connections in GNS3. This will emulate a wireless connection, even though it is technically a wired connection.
Yeah.
Step 3. Configure wireless settings, SSID, and security. Configure the wireless router with appropriate SSID and security.
All right. So the first thing we need is a wireless image, which I don't even think I have that right now. And I don't even think I have, like, maybe it would be a guess. McJoin? I don't know what that is. There's a lot of like microtech. Is that wireless? Like what is this? Or like Open V switch, can that do wireless? Yeah, I don't even think I have a wireless image here. Oh, I think this is it. I think WLC stands for wireless LAN. Yeah, cool. Okay, we got it. We got it. Now we need access points as well. Cool. And we've got Citrix SD WAN, but that's not wireless. We need access points. But let's see if we can get this wireless LAN controller. Oh, is this it? What's a PYATS? What is a Cisco PYATS?
Cisco PY. ADS is a Python framework developed by Cisco. It is designed to help network engineers automate network testing and validation. Here, I will break down the core components and functionalities of Cisco PYADS.
Oh, really?
Core components. PYADS library. A Python library providing the foundational building blocks for network test automation. It includes modules for test case management, logging, parallel execution, and more. Genie. Built on top of PYADS, Genie is a library that simplifies network automation and testing. It includes parsers to transform CLI outputs into structured data, Python dictionaries, which can be easily manipulated in Python scripts. Robot framework integration. PYADS can be integrated with the Robot framework, a generic open source automation framework for acceptance testing, to create comprehensive network test suites.
That's cool. All right, but this is what we need, is this wireless LAN controller. So let's see if I can get that. Sometimes you don't even need, like, sometimes it'll just take you right to the file and you don't even need to do anything. Like, you just need to create an account, or like it's right there and it's free. So this looks like, yeah, it looks like the images are here, but yeah, we see this locked. Now this is a different symbol, but that's an upgrade. So I think this is you know, even it looks like even when you buy it, you need a license after you buy it. So I don't think this is going to work. It's locked, see? Yeah, so it's locked. Even if I were to log in, I don't have a professional service contract. So, yeah, kind of dead in the water with that. Is there any like open source wireless controllers and wireless access points that I can use in my GNS lab, so I don't have to make sure that I have the images in a legal and ethical way? And ethical, not unethical.
Absolutely. There are indeed open source solutions available for simulating wireless networks. Here are a couple of solutions you might consider. 1. FreeRadius. While not a wireless controller per se, FreeRadius can act as a backend authentication server for wireless networks, helping you simulate the AAA, authentication, authorization, and counting aspects of wireless network.
Cool.
2. HostFD. It is a user space daemon for wireless access points and is widely used in a variety of open source and commercial wireless solutions. It can help you simulate a wireless access point. 3. OpenWRTA, an open source project that provides firmware images for a wide range of wireless routers, effectively turning them into wireless access points with a wide range of features.
Yeah, we should use that.
While it's typically used on physical hardware, it's possible to run OpenWrt in a virtual environment, potentially allowing you to simulate a wireless network in GNS3.
Yes.
4. Zero Shell. It is a Linux distribution for servers and embedded devices aimed at providing the main network services a LAN requires. It is available in the form of live CD or compact flash image, and you can configure and administer it using your web browser. Setting up in GNS3. To set up these solutions in GNS3, you would generally follow these steps.
Perfect. Okay. Yeah, so you can use like open WRT. So it's like yeah, so what is it used for? Control over router from wireless router. Oh, that's cool. I should try that. I should try that on my router. That's cool. Yeah, we definitely need to try to use OpenWRT. So let me say this. So let's say that I go with OpenWRT in the real world as part of a job and I need to set it up. Explain to me the kind of hardware that would need to be purchased in order to use OpenWRT, and explain to me the kinds of considerations I would make when it came to how much I needed to budget for the hardware expenses.
Using Open WRT in a real-world scenario involves installing the firmware on compatible routers to customize and optimize your wireless network according to your specific needs. Here's how you can go about selecting hardware and budgeting for OpenWrt deployment. 1. Hardware selection. Compatible routers. The first thing to note is that OpenWrt can be installed on various routers, including but not limited to TP-Link, NetGear-Link, SysD-Link. Hardware specifications. Consider the following specs based on your network demands. CPU. More powerful CPUs will handle more simultaneous connections and higher throughput.
Yes.
RAM. More RAM allows for better performance and more clients connected. Flash memory. Needed for storing the firmware and other files. 16 megabytes is generally the recommended minimum. 2. Network requirement. Size of the network. Small networks, home or small offices. Budget.
Yeah.
$50 minus $150 per router. Hardware. Mid-range routers, medium to large networks, medium to large enterprises. But
so if you're just buying routers, mid-range routers that are like TP-Link, NetGear, Linksys, and D-Link for a small home or small office network, I mean, even if you are buying like a high-end router with better throughput and advanced features, then what good is OpenWRT? Why not just use the firmware that they come with?
Using the default firmware on routers is indeed sufficient for many users, especially those with basic networking needs. However, utilizing OpenWrt can offer a range of benefits, even for home or small office networks. Here are some reasons why one might prefer using OpenWrt over the default firmware. 1. Customization and flexibility. Granular control. OpenWrt allows for more granular control over the router settings compared to the default firmware, which tends to offer a more simplified interface.
Well, give me some examples of the custom features.
OpenWrt can provide more detailed logs and monitoring options compared to many default firmware. Traffic analysis.
QoS.
Gain insights into the network performance and the behavior of connected devices. 5.
Traffic analysis.
VPN and other advanced features. VPN. OpenWrt can facilitate the easy setup of VPN services on a router, which might not be supported or might be limited in the default firmware.
Ad blocking would be
Set up network-wide ad blocking using packages like AdBlock or Simple AdBlock.
That would be
6.
worth it.
Extend the life of the router. New features. Even if a manufacturer stops supporting a router model, you can potentially add new features and maintain security.
That would be huge as well, because you could get like a huge beefy. Like let's do that. So let's look at some of these. So we'll go on like eBay or something. So you could get like a beefy router. Yeah, so like here's so you can use old gear and still have it be secure and still have it like work pretty well, I think. I don't know. But the thing is, like, old gear is always going to be pretty like bad. Like, you know, the way, like, what was the CPU on this? Yeah, so I mean, it's hard to get like the CPU and RAM specifications, but like maybe that's something you could do is let me ask you this. So okay. So what are the custom features that you could get that you couldn't get in the default firmware that would make all this extra administrative work worth the time and effort?
Absolutely. The extra administrative work involved in setting up and maintaining an OpenWrt environment can indeed be worth it given the additional features and functionalities it can offer. Below are some of the custom features you might not find in default firmware that can make OpenWrt a worthy choice.
Oh, VLANs can be nice.
Advanced network configurations. VLAN support. More comprehensive VLAN support to segregate your network effectively. Multi-WAN. Setting up multiple WAN connections for load balancing or failover. 2. Enhanced security features DNS over HTTPS TLS, ensuring that your DNS queries are secure and private. Custom firewall rules. Creating sophisticated firewall rules for improved network security. 3. Quality of service, codes, and traffic shaping. Layer 7 traffic shaping. Prioritize traffic based on the type of application being used. Bandwidth monitoring. More detailed bandwidth monitoring to keep an eye on network usage. 4.
Yeah, that could be nice. Okay, yeah, that could be worth it. So, yeah, we do need, if we can get one of these images, maybe an older one is available. Let's see where it lands us for all of these. There might be like a really old one that is available. Nothing yet. See, what I was thinking you could do is, and I'll ask the AI this. See, what I was thinking you could do, and what the advantage of something like OpenWRT would be, is you could just buy some kind of motherboard, and you can slot modules into the motherboard, such as wireless network interface cards, and then you can beef up the system with as much RAM and CPU as you would like. You can completely max out the motherboard and build this monster machine with all the capability in the world, and the only thing you would be missing, where instead you would buy from a beefy Cisco offering or something like that, or even just the nicer Linksys home routers, is you would be missing the routers. You would be missing the wireless routers firmware, but you could just install Open WRT onto your just basic home-built thing that you made that just consists of a motherboard and all the components you needed connected together, and you could save huge money on really beefy, powerful systems that normally you would have to not only pay for from a vendor, but have to buy like licensing fees and all of this extra stuff that you wouldn't need for just a computer that you built yourself for this purpose.
Here. Absolutely right. Leveraging a solution like OpenWrt can indeed allow you to customize a high-performance network infrastructure at a potentially lower cost, while avoiding vendor lock-in and recurring license fees.
Exactly.
Let's delve a bit deeper into your approach.
That's what I thought you could do.
Custom OpenWrt Router 1. Hardware selection motherboard. Start with a motherboard that supports a large amount of RAM and has sufficient PCIe slots for network cards.
Right.
CPU. Choose a CPU with a good balance between power efficiency and performance. RAM. Equip it with a substantial amount of RAM to handle various services and applications smoothly. Storage. Opt for a reliable SSD to host the OpenWrt system and any other services you might want to run.
So you need like a few
network interface cards, NICs, wired NICs
and stuff.
Get high-speed wired NICs for LAN and WAN connections. Wireless NICs. Purchase wireless NICs that are compatible with OpenWrt to establish Wi-Fi networks.
Yes.
3. OpenWrt installation compatibility. Ensure all hardware components are compatible with OpenWrt. Installation. Install OpenWrt on the system, leveraging its features to set up and manage your network. 4. Advanced network configuration modularity. The modular setup allows for easy upgrades and replacements, avoiding complete system overhaul for minor upgrades. Cooling system. Set up an efficient cooling system to manage the heat generated by the powerful hardware. 5. Customization and services. Custom services. Set up custom services such as VPN servers, ad blockers, etc. On your OpenWrt system. Scripting and automation. Use the OpenWrt environment to create custom scripts for network automation and monitoring. Benefits. Cost efficiency. Potentially lower initial costs compared to high-end commercial routers. No licensing fees. Avoid recurring licensing fees that come with commercial solutions. Customization. Create a network that is tailored exactly to your needs, with the ability to upgrade individual components as necessary. Performance. Leverage high-performance hardware to create a powerful networking solution. Considerations: technical expertise. Requires a higher level of technical expertise to set up and manage compared to commercial solutions.
I mean, compared to commercial
Limited support compared to commercial solutions. You'll largely be on your own in diagnosing and resolving issues.
Like, we're comparing it to commercial solutions. It's literally meant for your grandmother to set up. So it's like, no, it doesn't require that high of a level of technical expertise. If you can tie your shoes, you can do this, in my opinion. So, like, what? So let me ask this. Okay, so let's build this machine then. Give me the project management essentials for completing this project. Give me the budget and the timeline it will take, and give me what I need to consider in order to build a machine that meets my needs.
Absolutely. Let's break down the project into several crucial phases, each with its distinct objectives and tasks to undertake. Phase 1. Requirement gathering and analysis iteration. 1 to 2 weeks budget. And task 1. 1. Identify and document the specific needs and goals for your custom router. Task 1. 2. Research on the compatibility of OpenWork with various hardware components. Task 1. 3. Set a preliminary budget based on the initial analysis. Phase 2. Hardware procurement duration. 3 to 4 weeks budget. $1,000 minus $3,000. This is a ballpark estimate. Actual costs may vary based on your specific requirements and hardware prices at the time of purchase. Task 2. 1. Identify and list potential vendors, suppliers. Task 2. 2. Procure the necessary hardware components. Motherboard. $200 to $500 CPU, $300 minus $600 RAM. $100 minus $300 storage, SSD. $100 minus $200 network interface cards, NICs. $200 minus $500 cooling system. $50 minus $150 power supply. $50 minus $150 case, enclosure. $50 minus $100 phase 3. Assembly and initial setup duration.
Man, that's a lot of money. You can get a commercial router for like $50. Why do we need to spend so much? Why do we need to spend that much? You can get a commercial router for like $50. What do we get through this project that we wouldn't get otherwise? A high-end, yeah, okay. Yeah. Okay, that makes sense. Oh. And they can get it down to like 3,500. See, this is the RAM, like, 2 to 4 they took me down from they took me down to like half the price. So they were probably like at 8 before. See, and you're going through USB. It's like you're having all of these, and this is the other thing I don't know either. It's like these will have their own wireless, Wi-Fi cards in them. A PC like this, an all-in-one PC. But I don't know if you still need this one. Yeah, I don't know. I feel like a lot of like wireless routers like you can just like get for free. But the point is like, you want it to be beefy. So like let me do this. So okay. So here is an example of a commercial router I could purchase whole. So it would cost whole how much would this cost? Oh, gotta click buy now. Oh, it would cost like under $100. It would cost under $100. Please explain the limitations of this device, and for each of its features, why building a custom machine that uses OpenWRT so for what real world scenario building makes more sense?
Certainly, let's discuss the features one by one and how a custom machine with OpenWrt could potentially offer more. 1. Wireless Standard 802. 11 AC Commercial Router Pros. Supports relatively modern wireless standard, offering fast wireless speeds. Cons. The 802. 11 AC standard, while fast, is not the latest standard. Newer devices support Wi-Fi 6, 802. 11X, which offers better performance and efficiency. OpenWrt Custom Build Pros. You have the option to incorporate a Wi-Fi 6, 802. 11X card, providing better performance and future-proofing your network. Real-world scenario. A household with many Wi-Fi 6 enabled devices would benefit from the improved performance and efficiency of a Wi-Fi 6 network. 2. Simultaneous dual-band connectivity Commercial Router Pros. Offers dual-band connectivity, which can help to reduce congestion and interference. Cons. Limited to the maximum throughput specified. OpenWrt Custom Build Pros. The potential to add even more bands and higher throughput depending on the wireless cards you select. Real-world scenario. In an environment with a high density of devices, having more bands can help to reduce congestion further. 3. USB port for file sharing Commercial Router Pros. Easy to set up a simple network attached storage, NAS solution. Cons. Performance and features may be limited compared to a dedicated NAS solution. OpenWrt Custom Build Pros. Can set up a more robust and performant NAS solution with better hardware. Real-world scenario. A small business that requires a robust NAS solution with higher performance and features will benefit. 4. Guest Network Access Commercial Router Pros. Allows for simple guest network setup. Cons. Features and customization options for guest networks might be limited. OpenWrt Custom Build Pros. Offers more advanced customization and security features for guest networks. Real-world scenario. A business that wants to provide guest access with more advanced security and customization options. 5. Ease of setup and management Commercial Router Pros. Generally easy to set up and manage, suitable for less tech-savvy individuals. Cons. Limited customization and advanced features. OpenWrt Custom Build Pros. Allows for deep customization and the potential for more advanced network setups. Cons. Requires a higher level of technical knowledge to set up and manage. Real-world scenario. Network enthusiasts, small business owners, or IT professionals who want a highly customizable network solution would find a custom build more fitting. General limitations of commercial router limited hardware. Fixed CPU, RAM, and storage, which can limit performance, especially in a network with many devices or high traffic. Limited software features. The default firmware often offers limited features compared to what you can achieve with OpenWrt. OpenWrt Custom Build advantages hardware upgradability. Can upgrade individual components as your needs evolve. Better security. Can configure more advanced security settings and features. In summary, a custom build offers more flexibility, future-proofing, and features at the cost of a higher initial setup complexity and potentially higher costs. It's best suited for scenarios where the additional features and performance would be beneficial.
Okay. But in that sort of situation where the higher initial setup complexity and potential higher costs are desired, and scenarios with additional features and performance require getting a sophisticated modern device, aren't you just better with going with like a beefy, robust Cisco wireless offering, or whatever large enterprise offering there are through big companies like Cisco or Juniper? Does building your own ever actually make sense, or are you better off either just buying a commercial router that is totally fine for the here and now, and then upgrading that router if you need more later, or just biting the bullet and going with the expensive, most modern, cutting edge solution through Cisco or Juniper.
In most real-world scenarios, especially in enterprise environments, opting for established vendors like Cisco or Juniper does indeed offer substantial benefits over a custom-built solution using OpenWord. Let's delve into when each solution might make the most sense. Commercial router, like your TP-Link AC1750, use cases. Home networks, small offices, temporary setups. Pros: cost-effective, easy to set up and manage. Cons: limited customization and scalability. May lack advanced security and management features. Enterprise solutions, Cisco, Juniper, etc. Use cases: medium to large businesses, corporations, campuses, etc. Pros: comprehensive support and warranty. Advanced security and management features. Scalability and integration with other enterprise systems. Cons: high cost. Can be complex to manage, often requiring trained IT staff. Custom build with OpenWRT USE cases. Network enthusiasts, small startups with specific needs, educational purposes, etc. Pros: customizable to a highly specific degree. Can be built to specification, potentially offering a middle ground between commercial routers and enterprise solutions. Cons: lack of official support, you are essentially your own tech support. Potentially higher complexity in setup and maintenance. Analysis: small settings, home, small office. Commercial routers usually suffice, offering a good balance of ease of use and functionality for a lower cost. Medium to large enterprises, established vendors like Cisco and Juniper are generally the go-to solutions. They offer robust, scalable solutions with professional support and integration capabilities. Specific use scenarios: learning and experimentation. A custom build with OpenWord can be an excellent educational tool for learning about network management and configuration. Specialized use cases. There might be very niche scenarios where a custom build could fulfill specific needs more cost effectively than an enterprise solution, although such cases would be relatively rare. Conclusion: while building a custom solution with OpenWord can be a rewarding project, especially for learning and experimentation, in most practical, real-world scenarios, opting for either a commercial router or a solution from an established vendor would generally be the more sensible choice. Established vendors offer solutions that are scalable, robust, and come with professional support, making them suitable for a wide range of environments, from small businesses to large enterprises.
Alright, I ran out of batteries in my mic check went, and I'm quiet now, so like I have to change the batteries in my headset, so I'm gonna try to cut this really short. So this makes sense to me now. Yeah, OpenWRT kind of doesn't make a lot of sense, but you know, of course it doesn't. Otherwise, everyone would be using that. So where it does make sense is if you want this middle ground, you don't want how much is like the Cisco big enterprise, you know, for your football stadium, you know, you're probably going to want to just go with that if you have a modern cutting edge football stadium. But let's say you have like a junior, you know, or like a high school football stadium, and it's just like overkill. Like it's just not that beefy, but at the same time, you know, it's not like your grandma's apartment. It's like there's real traffic going on. There's a lot of stuff, but like, you know, it's not quite there yet for like the big thing. So like, you know, that might be a good example of like where you need like a middle ground. It's like you can't quite do it with like commercial gear, but you know, like business, like first class gear, it just doesn't quite make sense, especially like if it's a temporary thing. Like you can think of like a almost like Burning Man would be a great example, you know. And then of course the second use case where it makes a ton of sense is like my use case here, where I can't get access to these images. So if I can get access to open WRT, then I can simulate wireless in my lab, so it makes all kinds of sense. So yeah, I think that's going to be it. We got the lab all cabled up, we got all the devices out. We are missing like wireless, all that, so that's okay, but I'm going to end the video here. We might need to do one more video to get in-band management access set up to everything, so that we've got those prerequisite steps for automation there. Just for this book. Eventually I would like to develop some kind of day zero automation, but for now we're just gonna try to get this book done and then move on to learning about cloud, you know, the things that'll actually be more important for me to learn about. So yep, that's it for this video. Thanks for watching, and see you in the next one.